All right, so here's a tough question. You will definitely want to put this into your TI-84. I'm just going to graph what this looks like. If I graph y sub 1, this should say y sub 1, is equal to 1 plus 1 over x, all of that to the x power, it's going to kind of go through where e is. Remember, e is about 2.7. So I'm going to put a horizontal asymptote there, and I'm going to graph kind of what this graph looks like. Again, my drawings aren't of perfection, but I think you know that by now. It's going to look like this. So they say evaluate the expression for decreasing negative values of x. So what's happening as x is decreasing? What is happening to the y? So remember that this is y sub 2 is equal to e. So as x decreases, the y value gets closer to the line y equals e. So that's what's really happening. Now, if you go ahead and hit second table, you can see that from the table, it's going to keep getting smaller and smaller and smaller. So this graph right here will approach the line e as x approaches negative infinity. So even though it looks like it might eventually pass through this line right here, it's never, ever, ever, ever going to touch that line. It just gets closer and closer. The next questions are just asking you to put this into your calculator. So on your calculator, you're going to take this equation right here, f of x equals e to the, and the first one is going to be to the 6.2. And when I put in 6.2, I get 492.7490. It does say to write the value to 4 decimal places. When I put in negative 0.4, I get 0.6703. When I put in c, negative 7.1, I get 0.0008, because again, 4 decimal places. And when I put in d, 0.72, I get 2.0544. The next question tells us to sketch this graph. So remember that this graph is anything to the 0 power is going to be 1. But now this graph has 5 times. So if I was to put this into the 0 power, we would have to know where that is. So let's go ahead and build our graph. And let's do 5, 10, 15. So remember when I put in, if I was to make a table and plug in numbers, when I plug in 0, I get 5 times 1. So I know that it's going to go through this point. Okay? You might want to just look at this in the graphing calculator, but remember we always want to know how to be able to plug in plug in numbers. So you should be able to plug in all these numbers and graph it on your own here. All right, because we know it's a regular exponential function, it is going to look like this, and it will never, ever, ever, ever touch the x-axis. If you guys forget anything your year of pre-calculus, it's this formula right here, so write it down. Okay, if you would like to look at them, they're on page 186 in the yellow box. Formulas for compound interest after t years, so remember the number t has to be in years, the balance a in an account with principal p and annual interest rate r in decimal form is given by the following formula. A equals p times 1 plus r over n to the nt, and for continuous compounding, you should know a equals p e to the rt, and yes, that is the natural logarithm e. So a total of $4,000. Where would I put that $4,000? We know A is equal to, I'm going to put that $4,000 for the principal. So if you know anything about investing numbers and investing money, this is how it would work. And it says that it's invested at an annual interest rate of 5.25. So remember, we want it in decimal point form. So 0.0525. And it's compounded monthly. So how many times in a year would be n? That's going to be 12 times in a year. And then I know that the time is a year, 12, but they want to know how many months, so we're going to put in 6 months. One of the hardest parts is actually putting this in on your calculator. When I do calculate this, remember we're talking money, I have $5,477.27. Now, just FYI, you can put all of this right here into a graphing calculator and hit the graph at 6 years. You can see when you hit second table, you can see that the table is going to be right at $5,477.27. Probably easier to do it by hand. Great job.